what is the average time to read a 4 KB page for a for a typical disk with 128 sectors per track, 512 bytes per sector, and rotating with 6000 rotations per minute? The average seek time is 10 milliseconds. This is 10 milliseconds, and the controller overhead is 1 millisecond. Here rotation of the disk is given as 6000 rotations per minute. So time for 1 minute, that is 60 seconds, it is rotating at the speed of 6000 rotations. So for one rotation, how much time? For one rotation, how much time? So we'll be getting for one rotation time will be getting as 5 for one rotation time would be 1 by 60 1 by 6000 into 60. So 100, 1 by 100, 1 by 100 seconds, which is nothing but 10 milliseconds. So for one rotation, the time taken is 10 milliseconds. In one rotation, we can read one track. So here capacity of one track is given as here it is given that there are 128 sectors for one track. So 128 sectors into, and sector size is given as 512 bytes. So this is 2 power 7 into 2 power 9, which is nothing but 2 power 16, that is 64 KB. So 64 KB is the capacity of the track. That means we can read 64 KB. We can transfer we can transfer 64 KB in 10 milliseconds. We need to read 4 KB. So 64 KB 10 milliseconds, 4 KB, how much time? So this is nothing but 4 by 64 into 10. So if we solve this, we simplify this, it is approximately equal to 0.6 milliseconds. That is we got transfer time. So total time taken to read the page is, total time is equal to, this total access time is equal to seek time plus transfer time plus controller overhead. So seek time is given as average seek time is given as 10 milliseconds plus transfer time we got as 0.6 milliseconds plus, and the controller overhead is given as 1 millisecond. So if we add this one, we will be getting 11 point. Here we forgot one thing. Total time is nothing but seek time plus transfer time plus controller overhead plus rotational latency also. Rotational latency is nothing but half of the time taken to complete one rotation. For one complete rotation we got 10 milliseconds, so rotational latency will be 5. So we should add plus 5 also, 5 milliseconds for rotational latency. So if we simplify this, we would be getting 16.6 milliseconds, which is option A. Here total accessing time is seek time plus transfer time plus rotational latency. Rotational latency is nothing but half of the time taken to complete one rotation plus controller overhead. So this is the total time to read 4 KB page. So your correct option is option A.
Checksum for the message 100101101 using a CRC generator polynomial x square plus 1. CRC means cyclic redundancy check. So here x square plus 1 can be written as 101 because x term is 0, x square term is 1, and when there are 3 bits in the generator, we have to add two zeros, 1001 011 01. For this 2 zeros must be added. We have to divide this with this generator 101. So 101 once because it is 101. So this will become 01. This 1 should be taken down, and then 000 because it is 0 here. Then 11. This 0 will come down here. Again you have to with 101 exclusive OR operation actually. 1 exclusive OR 01 and 0 exclusive OR 1. Again this 1 will come down. Again with 101. This will become 10. Again this 1. So again with 101, this will become 00. Again 0. With 0 we have to perform 000. This 1 you have to get down. Again with 0 1. Again 0, it will be 0. Again 0 1 0. Again 0 you have to get down. Then with 1, again 101, you will get 01. Finally we are getting 01. 01 is the CRC reminder. So option A is the right option. Consider the following transitions of the Turing machine: delta Q0 A, Q0 A right, Q0 B, Q1 B right, Q0 blank, QF blank right, Q1 A, Q0 A right, Q1 B, Q1 B right, Q1 blank halt, QF is halt for every input. So now let Q is equal to Q0, Q1, QF, sigma is A comma B, tau is A comma B comma blank, and F is QF. What is the language accepted by the above Turing machine? Option A, strings that do not end with A, B, strings that ends with A, C, strings or sigma is equal to A comma B that do not end with B, none of this. So if you take all are going to right side, majorly other than final state we are having two states, Q0 and Q1. Q0 A is Q0, Q0 B is Q1, and Q0 blank is QF, means Q0 will be the final state. With Q0 blank only you are going to final here, means Q0 is the final state. Q1 A is Q0, Q1 B is Q1, Q1 blank is halt. That means this is the DFA equivalent DFA because it is a regular language only. So it is accepting all strings end with A plus epsilon. That means all strings end with A plus epsilon means it do not end with B. Okay, that is option C is the right option here.